So let's say another example of stoichiometry reaction. So let's suppose we have N2 plus 3 moles of H2 combining to form 2 moles of NH3. Okay, so for example, initially it was 1 mole, it was 3 moles, and finally both would be exhausted to form 2 moles of 2NH3. So in other terms, we can say that it was 1 volume, 3 volume consumed to form 2 volumes of 2NH3 at constant temperature and pressure as V is directly proportional to N. We have seen this law in the law of chemical combinations. Okay, next, the question is you have to calculate volume of CO2 formed at 2 atm pressure and 927 degree Celsius when 25 gram of CaCO3 is decomposed. When 25 grams of CaCO3 is decomposed. So by decomposition we mean CaCO3 is heated to result into CaO plus CO2. So we have to calculate volume of CO2 released. Okay, so the weight of CaCO3 used was 25 grams. Okay, so the moles of CaCO3 that would be used would be 25 divided by the molar mass of CaCO3 would be 100. So total 0.25 moles of CaCO3 were consumed. Okay, so now we know that moles of CO2 that would be released would be again 0.25. Hence, by applying ideal gas equation PV equals to nRT, we know the pressure, we know the number of moles, we know the gas constant, we know the temperature 927. Okay, so from here volume can be calculated. Okay, and you guys can go on and calculate it. So volume should come out to be 12.31 liters. Okay, next you have to calculate mass of CO2 formed. Mass of CO2 formed when 20 moles of CO or carbon monoxide reacted with 10 moles of oxygen. Okay, so let's write the equation. So the balanced equation would be, or rather let me first write the unbalanced or plain equation. CO plus O2 gives 2 CO2. Okay, so here carbon atoms are 2, so it has to be balanced with 2 carbon atoms are there. Now here we have 4 oxygen atoms. Okay, and so here also we must have 4 oxygen atoms, which is there in this case. Okay, so 20 moles of this compound reacted with 10 moles of this compound, so they will again form 20 moles of carbon dioxide. So the mass of carbon dioxide produced would be equal to number of moles multiplied by its molar mass. So from here you can calculate that it should come out to be 880 grams. Okay, next let's move on to next question, which is if 80 ml liquid X has rho or density as 1.2 gram per cc, then calculate the moles of X in, or simple, let's calculate the moles of X. Okay, so we have been given that the molar mass of X is 32 gram per mole. Okay, so just we have to see that density is mass of X upon volume of X. Okay, so from here we can have the mass of X as density into volume equals to mass of X, and moles of X would be mass of X, which is rho into V upon molar mass of X, which is 32. So from here you can calculate the value of moles of X. So it should come out to be, what is rho into V? 1.2 into 80, it should come out to be 96 upon 32. So number of moles would be 3. Let's see another example. So here we have, so let's say in the previous reaction wherein, or in the previous question which we saw there are 2 moles of CO actually reacts with oxygen molecule to form 2 moles of CO2. Okay, so let's say we had in that question we had it in, okay, it was present in 10 molar ratio compared to the CO. Okay, so in this case complete carbon monoxide and complete CO2 were exhausted as a reactants part, and the products what was formed, leaving no reactants back into the mixture. Okay, but let's say in this case we have 10 or 12 moles of carbon monoxide and we have 5 moles of oxygen present. Okay, so you can see that this is the initial phase, and what would be the final phase? In the final phase, complete oxygen would be utilized in the reaction and 10 moles of CO2 would be present, but 2 moles of CO would also be present because 2 moles of CO are in excess. Okay, because for consuming 5 moles of oxygen we only require 10 moles of carbon monoxide. So in the final state we will be having 2 moles of carbon monoxide also present in the mixture. Okay, so we can write that 2 moles of carbon monoxide will be present after the reaction. Okay, so in simple terms or in other terms we can say that CO is a excess reagent and O2 is limiting reagent. Okay, next let's see this example. We have N2 plus O2 gives rather N2 plus, we can write H2 gives NH3. So let's balance the equation. 2 hydrogen atoms are present, so we have to write 2 here. 6 hydrogen atoms are present here, so we have to write 3 here. So what are the stoichiometric coefficients here? It is 1, 3 and 2, and stoichiometric amount or stoichiometric amount for the initial phase would be 1 mole, 3 moles, and finally we would have 2 moles of NH3 present. Okay, but if we change the change means increase or decrease the any of the quantity of N2 or H2, it will be reflecting on the moles present of NH2, and one of the either would be limiting reagent and the another would be excess reagent. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing limiting reagent or limiting agent in depth. Okay, so we'll meet in the next lecture.